All right. Hello, my name is Arthur, and I'm from Area 52. And today I'm gonna present my presentation about localization detection using vision. So here's a general overview of what we're going to be going over today. So first, we're going to go over the general computer vision libraries in FTC. And we're also going to go over EasyOpenCV and how I used it in PowerPlay to localize our robot using junction pulls on the field. Next, we're also going to be talking about Vision Portal and the AbleTag API in Vision Portal. All right, so there are three main computer vision libraries in FTC. So first, there's AbleTag, and then there's TensorFlow, and then OpenCV. So today we're going to go over EasyOpenCV and the AbleTag API in Vision Portal. I just want to mention TensorFlow because it uses training data to detect objects. But for this presentation, I'm not going to be mentioning it much because it tracks too slow to be used for navigation. All right, so the first part is going to be over EasyOpenCV. EasyOpenCV is the FTC implementation of OpenCV, and it makes it really easy for you to create your first pipeline. And EasyOpenCV can do a lot of things such as detect color. So for EasyOpenCV color detection, first we're going to be using the HSV color space. The reason we're using it is because it can detect a range of brightnesses for a certain color. And what is HSV, you may ask? So there's three parts to HSV. There's hue, which is the color you want, and then saturation is the paleness of the color, and then value is the brightness and darkness of the color. To implement this in FTC, what you do is you want to create a high and a low threshold. And then next thing you want to do is convert it to HSV color space. And then using the thresholds that you defined earlier, you want to use the in-range function to threshold the frame. And this is what it should look like after you use the in-range function. So for the PowerPlay season, I use EasyOpenCV to develop a pipeline that can detect a junction and use it to localize our robot. So as you can see in the pseudocode on the right, we first filter out yellow color in the frame, and then we find the contours. And then the first for loop I made in this pseudocode. Basically, it measures the size of each contour, and based on its area, height, and width, we basically filter out certain pixels in the frame. The next for loop finds the closest junction. So in a case of a frame that has multiple junctions, you want to find the closest junction by finding the junction on the frame that has the biggest width. And here's a code snippet of the pipeline on Android Studio. So the first block of code filter out the color using HSV values that I predefined in previous line of code. And the second line of code uses the function find contours to basically find all the contours of all the pixels in the frame. And these two functions I will talk about later. They're basically the low-pass filter and the it basically finds the closest junction in the frame. So here's the functions at a closer look. So if you look at the left code snippet, it basically turns the contour we found in the frame, and then it turns into a bounding rectangle. So using this bounding rectangle, we can use the area, the width, and the height to determine to find actual junctions and to filter out unnecessary noise. The second code snippet finds the closest junctions, and then what it basically does is finds the minimum area rectangle. What this does is wraps the junctions wraps the junction with a rectangle. So what it will look like in the actual picture is that there's a rectangle around the junction that is rotated so that can fit the junction. And then using these rectangles, we can find the closest junction to us. So there are a lot of EOCV resources that you can use to develop your first pipeline. The first one I recommend is using EOCV Sim, as it can simulate your EOCV pipeline on camera, video, and image. So basically, you don't need a robot to do this. The second resource I also want to mention is OpenCV docs. So in the earlier slides, I talked about certain functions. So if you want to learn more about these functions, you can go to this link. Another resource that is also great is YouTube and Google. So the second part of the presentation is Vision Portal. So in the new 8.2 SDK, there's a new thing called Vision Portal that lets you use a lot of the computer vision libraries, and it'll also be replacing Vuforia in the center stage season. So for a general overview of Vision Portal, for the first part, you can use all three libraries, which include EasyOCV, TensorFlow, and AbleTag. There are also built-in camera calibrations. So since there are a lot of lens distortions on the edge of the camera, it will be a lot more accurate when you're detecting something. And then also it supports dual preview, so you can use two cameras at once. Here's a custom snippet of how to initialize Vision Portal. So in this code snippet, we're initializing a custom AbleTag that we can use to detect in Vision Portal. For the first line of block of code, it adds a custom library, tag to a library. And what you want to do with my recommendation is that you have to tune the size parameter. So you want to tune it so that the calculated distance matches up with a measured distance. And then the second line basically sets the library up with the processor. And then the third block of code sets the processor up with Vision Portal and also initializes the camera. In Vision Portal, there's also an AbleTag pose API that I want to go over. So this basically provides all the information about the pose of the AbleTag based on where the camera is and where the AbleTag is. So the first one is yaw. It's the heading of the AbleTag. And there's the bearing, which is the rotation you need to turn to face the AbleTag center. And then range is the direct distance from the camera lens to the tag center. Also want to mention, instead of range, you can also use the X, Y, and Z axes, as they're also basically derived range itself. With these values, you can create your own auto aim program or use it for localization in the next center stage. All right, so over the summer, I used these AbleTag pose information to create my custom AbleTag auto aim. So here's a video of it in action. So I want to mention it's pretty accurate itself. So if you want to use it for localization, I would highly recommend it next season. And as you can see, it's very accurate from all different angles and it parks right in front of the APO tag. All right, so these are the calculations I use for APO tag auto aim. So what I did is I first calculated the position and yaw of the APO tag from using the APO tag pose. And from that, I can calculate the rotation and position of the APO tag. And then I add an extra vector here, which is a set distance from the APO tag. So when I ever need to use auto aim, I can just park right in front of the APO tag so it won't run straight into it. And using this, I can use Roadrunner and use the line to spline heading to basically auto aim my robot straight to the APO tag. So for if you want to learn more about Vision Portal, I would definitely check these out. So FTC Docs is a great way to learn more about Vision Portal. And for the first link, I only talked about 3 types of APO tag poses. So if you want to learn the other poses, is a great resource for that. And second link provides more information of how you can initialize your Vision Portal. And also the third link I want to mention is since there's not a camera stream button for Vision Portal, you may want to use this to do your camera stream instead. And that's it. If you have any questions, feel free to ask.
Yeah.
If you had APO tag code in the past season, you can still use it, but what I'm saying is the navigation images they used in the past, it's all gone now and replaced with APO tag. So but the thing is, the game manual 1 says you cannot use APO tag on the team game element, so can't use it for the team game element. So I don't think you can use your code for that. Yeah. And are there any online questions? Okay, I don't think there are any online questions left, but thank you, Arthur. Okay.